What if everything on your wrist was designed to die? Except one thing that refuses to. Every year, millions of smart devices become useless. Batteries fade, software expires, and perfectly good technology turns into silent e waste. But there is a machine older than electricity itself that can outlive you and still keep perfect time. No charging, no updates, no planned obsolescence. Just gears, springs, and a heartbeat you can actually see. From the tickling pulse of quartz to the hypnotic sweep of mechanical motion, this is more than timekeeping. It's a battle between disposable tech and timeless engineering, a philosophy championed by masters like George Daniels. So before your next device dies, discover the one that won't. Subscribe, like, and share because this might change how you see time forever. Welcome to the channel. You are watching Wonders of Innovation.
We live in an era of disposable technology. Most devices we strap to our wrists are built with an expiration date, destined to be discarded and replaced. The watchmaker George Daniels observed that a battery-powered watch is entirely dependent on its power cell and operates with the dedicated ambition to commit suicide as soon as possible. Even with careful use, digital timekeepers face two inevitable failures: the chemical degradation of lithium-ion batteries and the eventual end of software support. These forces turn high-tech tools into e-waste within years. Yet, while digital tech decays, mechanical horology is experiencing a significant resurgence. People are returning to a technology that requires manual interaction and winding the crown just to keep it alive. These watches thrive because they offer an alternative to the cycle of obsolescence. They trade the temporary convenience of a microchip for the physical reality of a machine built to last. The difference between these two philosophies is visible in a single detail: the way the second hand travels around the dial. Quartz logic relies on a battery sending a single electrical pulse per second, creating a discrete, sharp tick. In contrast, mechanical movements use continuous energy. A series of microticks, 6 to 8 per second, blur into a smooth, sweeping glide. This sweep is the mechanical signature of the movement. It shows the device is operating entirely on its own, measuring time through the physical interaction of parts rather than electronic code. To see how that motion is sustained without a battery, we have to look past the dial and into the engine of the watch. The heart of this system is the escapement. Its job is to take the raw kinetic energy stored in a wound spring and regulate it into the precise increments we recognize as time. This happens through the constant action of the hairspring and balance wheel, which contract and expand several times a second in a controlled rhythm. In traditional watches, this release creates friction that eventually wears the metal down. George Daniels addressed this by developing the Coaxial escapement, which changed how parts interact. Instead of parts scraping against each other, the sliding friction shown here in red, the coaxial design uses a radial pushing motion, shown in green. This reduces wear and allows the watch to run longer between services. Innovations like this show that these machines aren't just relics. They are highly optimized systems of engineering designed to function for decades. Beyond the basic measurement of seconds, watchmakers build systems that solve much more complex problems, which are known as grand complications. While a smartwatch uses software to manage a calendar, a mechanical watch relies on pure geometry. Every calculation is performed by a physical component. Look at the density of this caliber. To calculate leap years or negate the pull of gravity through a tourbillon, watchmakers have to stack dozens of specialized gears into a physical algorithm. Manufacturing these parts requires microscopic tolerances, often machining components to within thousandths of a millimeter to ensure the algorithm functions reliably. Solving for gravity and time through geometry without using a single line of computer code is why UNESCO classifies the craft as intangible cultural heritage of humanity. This recognition also highlights the human element. The resurgence of mechanical watches is largely driven by independent artisans who favor craft over mass production. These timepieces are hand-finished and assembled by highly specialized experts, a sharp contrast to the automated assembly lines used for consumer electronics. It requires a steady hand to place individual, microscopic parts into a functioning architecture that fits on a wrist. This human assembly also ensures repairability. A sealed smartwatch is a black box. Once the internal circuit fails, it cannot be serviced. But a mechanical movement is an open platform. Decades after it is made, it can be disassembled, cleaned, re-oiled, and rebuilt by a skilled watchmaker. Longevity and serviceability define this form of luxury. A mechanical watch is built with the explicit expectation that it will outlive its original owner. When you put the watch on, the relationship between you and the machine becomes physical. There is a kinetic bond here. Your own physical movement swings an internal weight that charges the power reserve, keeping the system running through your daily activity. Digital devices often force us to see time as a series of notifications and deadlines to be managed. Mechanical horology offers a different perspective, connecting the wearer to centuries of engineering and the patient rhythm of the gears. Ultimately, these watches offer a counterpoint to the digital era. They trade the short-lived perfection of a microchip for the physical reality of human craftsmanship.
In a world driven by rapid upgrades and constant replacements, our relationship with technology has become increasingly temporary. Most modern devices are designed for convenience, but that convenience comes at the cost of longevity. Batteries degrade, software becomes outdated, and within a few years, even the most advanced gadgets lose their relevance. This cycle has normalized disposability, turning innovation into a short lived experience rather than a lasting investment. Mechanical watchmaking stands in direct opposition to this trend. Visionaries like George Daniels emphasized that a truly great timepiece should not depend on something as fragile as a battery. Instead, it should rely on enduring engineering, systems built from metal, motion, and precision. These watches are not just tools, they are living machines powered by interaction and care. What makes mechanical horology remarkable is its commitment to performance and permanence. Each component is designed to be serviced, repaired, and preserved. Rather than becoming obsolete, these watches evolve through maintenance, often lasting generations. This creates a deeper connection between the wearer and the object, one based not on consumption but on continuity. In many ways, choosing mechanical over digital is not just a preference, it is a statement about valuing craftsmanship, sustainability, and time itself.